Now, I promise to get your hands dirty, and I don't want to bore you with too much theory, so let's compromise some systems. We performed a vulnerability scanning, and you'll certainly remember that there was an exploitable vulnerability in the Java RMI service of the Metasploitable system. So let's exploit the Metasploitable. Here we are in the MSF console, so you can use the search command to find the exploits for Java RMI server insecure default config vulnerability. Here we find 2 auxiliaries and 2 exploits. To use the exploit, we use the use command of MSF console. Give the full name of the exploit you see. And you see the command prompt shows us which exploit or auxiliary that we are using. Now we can select a payload, type show payloads to see the payloads available with this exploit. You're going to see different payload lists for different exploits, but we have to choose one of these payloads. But you know something? I'd like to pause here for a bit for a little bit of definition. Sorry for that. I know you're chomping at the bit, but I'd like you to understand what it is that you're actually doing. So there are 3 different types of payload modules in the Metasploit framework: singles, stagers, and stages. These different types allow for a great deal of versatility and can be useful across numerous types of scenarios. Whether or not a payload is staged is represented by / in the payload name. For example, Windows/shell bind TCP is a single payload with no stage, whereas Windows/shell/reverse TCP RC4 consists of a stager, reverse TCP RC4, and a stage shell. So singles are payloads that are self-contained and completely standalone. A single payload can be something as simple as adding a user to the target system or running calc.exe. These kinds of payloads are self-contained, so they can be caught with non-Metasploit handlers such as netcat. Stagers set up a network connection between the attacker and victim and are designed to be small and reliable. It is difficult to always do both of these well, so the result is multiple similar stagers. Metasploit will use the best one when it can and fall back to a less preferred one if it's necessary. Stages are payload components that are downloaded by stagers modules. The various payload stages provide advanced features with no size limits, such as Meterpreter, VNC injection, and the iPhone iPone shell. Okay, so where were we? Right. We were about to set the payload for our exploit. To use the payload we want, we use the set payload Metasploit command. And look at that, you'll see that there are 2 popular types of shells, bind and reverse. A bind shell is the kind that opens up a new service on the target machine and requires the attacker to connect to it in order to get a session. A reverse shell, it's also known as a connect back, is the exact opposite. It requires the attacker to set up a listener first on his box. The target machine acts as a client connecting to that listener, and then finally the attacker receives the shell. So here I want to use the Java/shell/reverse TCP payload for this example. Type show options to see the parameters we have to configure. Now these are the parameters of the module, and these are the parameters of the selected payload. Required field shows if you have to fill in the parameter or not. If the option is required, it cannot be empty. So let's set the options for this exploit. Module options first. The first option is HTTP delay, which indicates the time that the HTTP server will wait for the payload request. It has a default value, 10. Just leave it as it is. rhost is the remote host, which means the target machine. In this example, Metasploitable, set rhost with the IP address of Metasploitable. Our port is the target port. As we've seen before, Java RMI service port of Metasploitable is 1099, which is the default value of the option. Serve host is another required field, which stands for the local host to listen on. Kali for us. So set serve host with the IP address of Kali. Serve post is another required field, the local port to listen on. And that has a default value of 8080. No need to change the default here. So the last three options are not required, so I'll just let them be with the default value. Now, let's set the payload options. Because it's a reverse shell payload, it asks the listener host's IP address and the port. Both of them are, of course, required. So set the L host, the listener address, as your Kali. And if you'd like, change the default value of the listen port. 4444 is fine for me. Now we are ready to run the exploit. And here you can use either run or the exploit command to run the exploit. Okay, so what the heck happened here? Let's look at the messages given by Metasploit. This module takes advantage of the default configuration of the RMI registry and RMI activation services, which allow loading classes from any remote HTTP URL. Here, it tries to exploit the vulnerability which is on the service running on the port 1099 of Metasploitable, using the application running on the port 8080 of our Kali. And finally, it says a command shell session opened, which means exploitation is successful. Now, because we don't need the HTTP server opened in Kali anymore, it's stopped at the end of the exploitation. Sessions command is used to see the session running in the background. We'll see the session command in details. Type session L to see the active sessions and sessions I1 to interact with the session which has the ID number 1. I think the interaction has started, so let's try it. I'll send the ls command, and yes, we now have the shell for Metasploitable. Print working directory, we are at the root. Who am I? We are the root user. If config to learn the IP address, it's 206, etc.